Assalamualaikum everyone. Welcome to the short lecture series on PIC 18F microcontroller, and today's topic is RISC architecture. Okay, let's start with the history of RISC architecture. We will go to the 60s era where mainframe and mini computers and large size computers were being in design process. So designers they could possibly put as many as instruction inside the CPU. What was the reason? So that the CPU can perform in every possible situation. But what happened with these kind of steps? Some of the instructions were so complex and they were designed to perform certain complex scenarios which happen only in real situations. So what was the bad thing here? The bad thing was those situations were rare. They were happening very infrequently. So what happened? The cost of implementing such complex instructions were very high, right? Because you were trying to do trying to cover every possible aspect which CPU can face, but those were maybe rare. And it was also becoming cost ineffective because CPU was using most of the time instructions which were designed for the simplified structures, for the simplified situations, but complex scenarios were not being so frequent, right? So such instruction set called complex instruction set computer, right? Or you can say it is the old or the traditional instruction set of computers, right? So that is why it is called CISC architecture, right? So any computer which follows these kind of architecture in which every possible scenario or every possible instruction is fed inside the CPU to deal with different kind of scenarios, right? In contrast to this complex instruction set computer architecture or CISC architecture, designers in 1980s realized that they could actually replace these complex instructions with simple and reduced instructions and small instructions which can effectively work in so many scenarios, right? So that architecture was called RISC architecture, which is the topic of this lecture. Okay, let's talk about the bright features of RISC architecture. So very first feature is fixed size instruction set, right? So all the instructions which are used in RISC architecture are having fixed size. So what is the advantage of having fixed size instruction? The fixed size instructions are very important because if your instruction is not fixed, then that means, for example, if your instruction is 8-bit long, the other instruction is 16-bit long, another instruction is 10-bit long. So what will happen? These instructions will take different variable time to get executed. So that is the very wrong approach, or you can say not optimized approach for microprocessor itself. So that means it will consume more time to process a same program, and it will consume multiple machine cycles to execute the same program. While if your program is good enough and written in fixed size instruction, then the machine cycle or instruction time, execution time is very constant. So it may make the pipelining procedure more easier. For those who do not understand pipelining procedure, there is a separate tutorial on my channel where you can see what is a pipeline mechanism. Okay, next feature which is important, RISC architecture has large number of data register. So if you talk about CISC, there were minimum amount of registers which were available internally, but in RISC architecture you have number of register, at least 32 registers in RISC architecture. They are there, and they actually make the life of programmer much easier because they do not do not to go to stake thing, which is a very complex architecture itself, and things become more difficult. So to avoid the stake, RISC architecture have a feature in which they can actually use a large number of data register. If any one of you don't know about stake, you can go and watch a stake tutorial on my channel, right? Small amount of instructions or basic instructions only, right? This is something which is unique. As I told you, the CISC architecture was following so many instructions or every possible scenario instruction, but in RISC architecture you have number of instructions very small, but they are fixed size, and you can perform all those complex things using these fixed size structures. So you do not have large number of instructions, but you can do all those magics which you can be you were able to do with the complex architecture. So small amount of instructions and it's very simplified, so it makes life of CPU more easy. Another important feature, since they are fixed size, they do not take large amount of time. So 95% of RISC architecture instructions, they are executed only in one clock cycle, which makes it faster. So they are kind of interrelated, fixed size instructions and one clock cycle thing, but they are important feature of RISC architecture. Okay, another important feature of RISC architecture is separate buses for data and code. These are very important feature, and they are related with Harvard and von Neumann architectures. For those who are aware about those architecture, this point is very easier to understand. You know that there are separate buses for data. If you are fetching data information from the data memory, then microprocessor is going to use a different path, and if it is fetching instruction from the program memory, then it is going to use the different path. While in CISC architecture, in contrast with RISC architecture, they were using the same kind of paths or same paths, and on turn basis they were fetching, sometimes they were fetching data and sometimes they were fetching code. So that means their life was a bit slow, but RISC architecture following microprocessor are faster because of this feature. Okay, it is a bit technical feature of RISC, but very important advantageous thing. And just to explain it, just before we understand it, we need to know what was happening in CISC architecture. So in CISC architecture, when instructions were so large and complex and variable size, so they were using almost 30 to 50%, right? How much? 30 to 50%, right? 30 to 50% of transistors of overall CPU, and sometimes this figure was approaching up to 60 to 70, right? So that means all the semiconductors which are fabricated, or TTL logics or transistors which are basically making up your CPU, they were actually being loaded up to 60 to 70% of overall machinery. But in case of RISC architecture, because instructions are very small and very small amount of instruction itself are present and they are fixed, so RISC architecture is using up to only 10% of overall CPU. That means your load is much low compared to CISC architecture. So there is no heating effect as compared to CISC. There is no delaying in as compared to CISC, because transistor to transistor propagation delay is reduced because of this less amount of transistors load, right? Okay. Another feature which is very important, and again, to understand this feature we have to go to CISC architecture. You know that in CISC architecture it was possible that if there is an external memory and there is a CPU register, and there was a data inside over there and there is some data over here, and you want to add these two datas, right, and store the result back in the memory. That was possible in CISC architecture, but since I told you that in CISC normally every possible instruction was written, so a separate instruction was written here for this purpose, though it was very rare scenario, so it was consuming more time, right? But in RISC architecture, what is happening, things are becoming more easier, that okay, this is your external memory and this is your internal CPU register, right? What happened, if you want to add this information, first you bring it here. So this is now here, right? This is one instruction of RISC architecture, and then you add them up here. It's quite easy, and then you store it back, right, over here. So that means what was happening in one instruction of CISC architecture, it is happening in three different instructions of RISC architecture, but they are fixed size and they are happening at the very fast rate. So that is why this is called load and store feature of RISC architecture. You load it first into your CPU and then you make the operation and then store back inside the external memory. So that is the feature of RISC architecture, which is making it very faster compared to CISC. That's it from this lecture. I hope you understand the benefits of RISC architecture, how things are becoming easier for both programmer and CPU itself when microprocessor or microcontrollers are following RISC architecture, in contrast to those microcontrollers which were following CISC architecture. That's it from this lecture. If you have any query or any feedback, please comment in comment section. Thank you so much for listening.